She is going to talk to us about proofs without words and Frege's philosophy of mathematics.
Okay, so I'll start by just recapping a little bit of what I talked about last time, and then I'll go into sort of the extension for this week, which is a particular person's philosophy. You can remember from last time that sort of figure on the left. I'm looking at these figures called proofs without words, which show mathematical results without using the sort of typical logical sentences to do so. So we looked at this one of the Pythagorean theorem last week, and so I just put it up there as a reminder of what these kinds of proofs without words are. And so they have appeared in the Mathematics magazine since 1975, and part of what I'm doing with my project is just going through and looking at all the proofs that have shown up. And so I'm into 1979 this year, and they're starting to appear more rapidly. I think there are 9 that showed up that year. And so part of what I'm doing is just cataloging some basic information about those and looking at them so that I can come back and draw on them for the sort of more substantial piece of my project, which is looking at a philosophical discussion about proofs. And these proofs without words, can they really be considered proofs, or are they just sort of useful, demonstrative, maybe pedagogical devices? And so by looking at the whole survey of proofs without words in Mathematics magazine, I have a lot of different examples that I can draw on. And I'll be talking about some of those specific examples as I get into Frege's philosophy today. So you can remember from last time I raised a couple of general questions at the end that have continued to guide my work. And one of those is when we look at a proof without words side by side with a logical proof, we might think that the proof without words is lacking something that makes it as good of a proof as the logical proof. And so to come up with more specifically what it is that would be desired to make that proof without words more of an actual proof as opposed to just a useful picture that supplements a proof. And then I also mentioned that we often associate rigor with axiomatic structure and deduction from known givens to new conclusions. And so if we have that structure, can proofs without words, which just sort of give you all the information at once, can they be considered rigorous proofs? And so those are 2 questions that I brought up last time, which I'll continue to discuss today as I get into Frege's philosophy. So just to introduce, I talked about my first presentation, and now I'm outlining today. I'll spend most of the time talking about a couple of aspects of Frege's philosophy. I'll give a little bit of background on Frege, talk about his context in the philosophy of mathematics, and then I'll talk about 2 of his important ideas. One is that there's this sharp distinction between psychology and logic, and the second is that he has a very clear idea of what the structure of proof is that fits with what a lot of mathematicians think about in practice, but he lays it out even more explicitly. And then to end, I'll talk about an extension of proof without words that I've started working on with Schuler. And I'll talk about the motivation for that extension, and I'll give an example. And basically what it is to make a proof without words more interactive using some new technology. And I'll conclude just briefly with next steps. So this is LKutler Frege. He's a philosopher and mathematician from the late 19th, early 20th century. And he did really important work in the foundations of mathematics and in analysis of the logical structure of mathematics. A huge part of his legacy is just what he gave to in developing modern logic. Most of what we had in logic until Frege dated all the way back to Aristotle. So this was the first major update. And even though many of his ideas have been discarded, a lot of his innovations in what we do in logic have been maintained, and there's still things that you come across when you're learning like first order kind of logic. His main thesis that he defended throughout a lot of his different works is called the logicis thesis, and you notice that the word logic is in logicis. And in general what that means is that math in its whole, everything that's mathematical, is reducible to logic. And so if you were to take math back to its most basic foundations, you wouldn't get anything that has sort of a special mathematical character, but it would just be like purely logical. And that's really important because something about logic, or people's idea of logic, is that it's necessary and it's very independent of us and our creation. So whereas some people think that we have to input some basic mathematical ideas or assumptions to start generating math, he thinks that we can trace it all back to logic. And so one of the works in which he defended this thesis and started laying out some of his logic is called Die Grundlagen der Arithmetik, published published in 2 volumes sort of during the middle period of his work, and so it kind of came after he started talking about some of this stuff, and afterwards he published something else, which gets into more of the formal characteristics of it. But a lot of it is just an explanation of his basic ideas about the philosophy of mathematics and the nature of logic. And so I'm going to get into talking about a couple of these main ideas in the next few slides. But one thing that becomes clear in the very beginning, the introduction to this book, is that there are sort of 2 main aims for mathematical proof. And so that's really relevant to these proofs without words, where we're trying to come up with what is it that makes a proof and not just sort of explanation or description. And so on the one hand, the aim of a proof is to establish the truth of a proposition beyond all doubt. And I'll get into talking more about what that means, but if we can trace all of mathematics back to logic and have these very clear and precise ways of deriving it, then it seems to make math extremely certain, gives it an infallible character, which is something that's important to him, and also objective. And the second aim of proof is that we come to see the dependence of truths upon each other. And so this is something that we're all familiar with from the work we've done in math, where you derive one result by relying on some other result, or in analysis where you can start with those axioms and then start to derive all of your other results. And so by going through this analysis and going through an even more detailed analysis into the foundations, you can really show the dependence of truths upon each other. And I'll back up because he's most interested in a second. First,